Okay. Hi, guys. I'm Tomek. Let me introduce myself. I'm a software engineering manager at a Swedish company called Seqr. We are doing mobile payments. We are a fintech company. And at the same time, I'm a DevOps lead at Kunlea. This is a DevOps Agile Skills Association for a member in Poland. Yeah, and you can reach me at Twitter and at LinkedIn if you wish. Okay. Before we start, I would like to be sure that we understand DevOps the same way. So at least my definition, or the definition I use, is that this is obviously a technology transformation that drives value to organizations through an ability to deliver code both at speed and stability, and it's about technology, but also process and culture. And I will be today mainly talking about processes and culture, and how leaders in organization can either reinforce the transformation or make it worse. And when speaking about DevOps, and this is, by the way, a definition by Nicole Forsgren, she's CEO of DORA, if you happen to know this organization behind State of DevOps report. What they say is that DevOps proved that speed and stability can be achieved at the same time. And the way to measure speed is to look at the lead time, so how much time it takes from a commit until it ends up on production, and what's the deployment frequency, obviously. And the thing is that high-performing organizations, on the ones who are able to apply DevOps principles, do this almost or more than 400 times faster, and deploy to production approximately 50 times more often. On the other hand, stability. The way to look about stability is failure rate, so how often we need to react after a deployment to production, and what is the mean time to recover once we find out that something is wrong. And again, high-performing organization, they have 5 times lower failure rates, and they are almost 100 times faster when recovering after failure. So those organizations achieved both speed and stability. And this is my definition of DevOps, and this is how I look at it. Okay, so to answer this question, we need to get back to the 60s or the 70s, because DevOps takes advantage of the lean movement. And Toyota succeeded in the 60s or in the 70s, not because they were selling crappy cars cheaper and faster, but because they were selling high-quality cars cheaper and faster. And if you go to the factories in the 60s and 70s, Toyota factories, the process looked more or less, of course, it's a very simplified way of showing this, but generally there was a car request, and there have been some steps, and then you get a car, right? The thing about Toyota is when you go to a dealership point and ask for a car or buy a car, it's not assembled yet. And it takes them 3 weeks to assemble it and deliver it to your dealership point. And how does it rely, or how does it relate to software? If you look at software as that there is some kind of business hypothesis, and on the very end there is a value delivered to a customer, there's a one point in between, which is a push-to-code repository, which is the vision point. And from the left, you should think more about driving a product and applying lean product development principles, like Scrum, for instance. And high uncertainty and variability is something natural, and you shouldn't counteract that. That's why Scrum and iterative ways, like every delivering value every week or every second week, is the way to deal with variability and unpredictability. On the other hand, once you deploy your code to production, once you push your code to the repository, this is the area of lean manufacturing and DevOps. And you want to have this process predictable and as little variable as possible, right? And actually, this kind of predictability we try to achieve with DevOps is an enabler for working with variability and uncertainty. So we're going to move in this on the left-hand side, how to create predictable and deliverable processes, right? So one of the first rules, if you want to manage something, you need to visualize that. So let's take a simple Kanban board. When you start seeing some work being done, maybe by different teams or maybe the same team, depends on the organization. And obviously, if you have silos in your organizations, like for instance here, so dev silos, what is the point of development team optimizing their work and being able to produce more features or user stories if we have a bottleneck in our system here in putting things on production. So the main thing is that some leaders don't understand that local optimizations, they produce suboptimal global solutions. And if you have different bosses, different departments, each of them optimize their work locally, it's not a guarantee that you will obtain faster lead times, for instance, when delivering stuff to production, because there may be a bottleneck, maybe here, right? Let's move to another example. Let's assume that our company builds houses, and to build a house, you need to build the cube of the house, then put roof on top, and then put a chimney. And you work for one customer, then you work for a second customer, and the third customer. But the reality doesn't look like this. Usually there are several project managers or several product owners. So once you start building one house, then there's another product owner or project manager approaching you and says, okay, what about my house? Okay, we are working on it, okay? We started working on it. So, okay, then another project manager comes, and we started working for 3 project managers or product owners in parallel, which most probably results in such a situation. Everyone is happy in the second scenario for sure, because we are working on their stuff, right? What about productivity measured here? I would say it's the same, because we produced 3 houses in the same unit of time. But what about time to market? From the red customer perspective, it's worse. From the blue customer's perspective, it's worse. It's the same from the green customer's perspective. So by not influencing any kind of technical processes or applying any technology, we're able to deliver things faster. And I omitted one thing on purpose, which is typical for human beings, which is context switching and its cost. In terms of project, it may mean setting up environments, setting up deployment pipeline, you name it. For human beings, it's just like we need time to context switch when working on different stuff. So in the first case scenario, when we focus on one thing at a time, it will look like this, whereas in the second case or second approach, most probably it would look like that. So then everyone has experienced the delay. And what leaders don't understand, some leaders, is that they optimize resource utilization. By saying resource, I mean people. I don't like this description, but this is how usually they call them, instead of optimizing flow. And maybe instead of starting, they should start finishing. And that's also a way how to improve lead times in your organization without even touching technology. Maybe we should focus on one thing at a time, if it's possible, of course. Let's move to another abstract example. Let's assume we need to send a letter. We have to print it, we have to fold it in 2, then we need to put it in an envelope, and then send it. How would you approach sending 1,000 letters? Maybe you can put it in batches. So print, I don't know, 100, 500, or maybe 1,000 of letters. Fold them 1,000 times. Put them in the envelope 1,000 times, and send them 1,000 times. And apparently there was a research done that people who were working in smaller batches did it better than people working in large batches. Why is it so? Because if you take into account quality, apparently, if you, if you take into account quality, and if you start working in large batches, like for instance the 1,000 letters, maybe at the very end of your process you will learn that you were folding the letters in a bad way, but you are not able to send them for a reason, or maybe they don't fit into an envelope, and then you generated a waste. So people who learn or do things in smaller batches, they have better feedback loops, or earlier feedback loops, which give them information about the quality of their work. That's why they do it faster. And the things which some leaders don't understand is that working in large, or they think that working in large batches allows them to deliver more value. And if I were to give an analogy to an organization, this is organizations trying to deploy things every 3 months or every half a year, because they think it's faster, they can do more work. But usually, at least to my experience, when the solution is so complex and the change is so big that it requires some heavy firefighting afterwards. Okay, so let's get back to the visualization example. If we happen to have several teams involved in the process, so every such work being passed, maybe from, I don't know, business analysis to development team to testing team to deployment team, is a handoff. And the natural part of a handoff is that information is lost and some context is lost. And the way to deal with this is that you can either try to automate the process, which DevOps is about. Automation removes context, losing a context and information loss, right? Or you need to reorganize the teams so that they work in the same, or there's no handoff between teams, but they work on the same flow of value in the system. And what some leaders don't understand is that the system they work in forces them to do politics instead of optimizing performance of a company. Because if I am a head of software engineering or head of operations, maybe the system is created in a way that I need to protect my garden, right? And I don't think about optimizing a flow because maybe it may threaten my position in a company. The second thing is that some leaders are just not empowered to do reorganization in their companies. And that's the second weakness. So what I discussed now is I was mostly referring to flow. So how to increase a flow of value from the left side to the right side, and what challenges leaders may face when doing this. Let's now move to another example. Those who had a chance to listen to me last year, I mentioned about Kinevin, and I think there is always a need to mention Kinevin. Who knows that? A few people. Okay, that's good. That's why I'm going to mention it. Kinevin is a way of first, what you need to do is to understand which problem you are solving. And there are 4 domains of problems: simple, complicated, complex, and chaotic. Simple problems are the ones where cause and effect are obvious. For instance, my license for IntelliJ expired. I need to buy a new one. That's a simple problem. Cause and effect are obvious. In complicated domain, we need to analyze, or after analysis, cause and effect are obvious. So, for instance, our solution needs to be PCI compliant because we are processing credit cards. This requires some analysis. Complex problems, on the other hand, are the ones where cause and effect are known in retrospect. And chaotic systems, cause and effect remain unknown even after they happened. And if you understand in which problem you are, then you can apply actions to solve those kind of problems. In simple domain, it's just, okay, sense, categorize what's the type of the problem, and just respond. So, okay, I have my IntelliJ license expired. I just need to organize money for that. I buy it, done. In complicated domain, okay, we need to be PCI compliant, or I don't know, anti-money laundering compliant. Okay, let's gather experts, let's think about it, let's design process in our company and implement them. This is a thing which you can solve when analyzing. But in complex area or in complex domain, analysis is not the way to deal with such problems. Maybe you should experiment, observe the results, and then respond either by amplifying your experiment or changing to another experiment. In chaotic systems, when aliens land in your city and start kidnapping people, there's no room for analysis, there is no room for experimenting. You just need to act, see how it goes, and then respond. And the key thing is that, at least to my experience, maybe not only mine, but the problems DevOps deals with are usually complex, and they require much experimenting instead of heavy analyzing stuff. And how does it refer to our everyday work? I mean, some leaders in DevOps transformation, they solve complex problems as if they were complicated. So they think that if they spend twice more time on analyzing something, they will end up with a better solution. Maybe instead they should just try experimenting, which is our example. I will show it later on, with continuous delivery and deployment pipeline. And if we accept that we are dealing with complex systems, then problems are natural part of those complex systems. And what does it mean? Maybe it means that instead of relying on prevention mechanisms like checklists, like heavy documentation, instructions, maybe we should build systems which can early detect problems before a catastrophe happens. And that's what DevOps or high-performing organizations do. They focus, of course, prevention is important. It doesn't mean that we should ignore it. But maybe we should build resilient systems which can detect weak signals and react to problems before the severity of consequences is high. And to achieve that is, of course, to recognize problems as soon as they appear. What does it mean? It means that if we, for instance, work in waterfall process, when we have a testing phase after the development, we limit ourselves for a very late feedback. So maybe when moving quality to the left, which was mentioned today several times, for instance, in terms of security, some leaders don't appreciate short feedback loops created, as I said, by moving quality or security checks to the left. And this is, for instance, obtained by having people in your team and having security or quality as a part of your definition of done and not being late in the process. So I discussed the feedback mechanism, which is the second pillar of DevOps. And if you look at the delivery, optimizing flow in the right direction, this is one part of DevOps. And second part of DevOps, or it won't work if we don't optimize or don't increase the flow of information and feedback in the opposite direction. And to give you an example, from our company, a couple of months ago, we drew a simplified value stream map for our deployment pipeline. So when the work is about to be delivered to production, the way we work, we have a feature branch, although now we are experimenting with working on a single branch, but at the time it was a feature branch. When you want to merge your code to the master branch, you do a pull request with a code review. After everything is fine, there's some side effects tests, automated tests are run. If everything goes well, we merge, or the code gets automatically merged to master branch. Then a given component is released. Components, they constitute a whole backend. It's another story, the architecture of our system, but it's not relevant now. When the whole backend is tested with the one component changed in it, automatically tested. If everything goes well, backend is released. Then we upgrade our staging environment automatically. Then automated tests are run on staging. And if everything goes well, there are some manual regression or sanity tests run. And if everything goes well, we enter the production. And that's the happy path. The not happy path looks like that first of all, code reviews done by other developers may result in getting back to feature branch and fixing something. Side effects may result in the same approach. Then some fix may be required, and you can end up there from a backend tests, automated tests on staging environment, or manual regression tests on production. And you get back to providing a fix in a master branch. And we started to compute what's the probability that when you enter a certain stage, what's the probability you will proceed. So in terms of side effects tested, around 60 to 70%. Almost 100% we are sure that we're gonna proceed later on. 100% again, then 60% of the tests, or 60% of the times we are proceeding further on. And then there's devastating 10%. So 10% of the times only we are able to proceed further on. So that's the bottleneck in our system. And this is a very long feedback loop. Sometimes it took us a week to travel through this feedback loop. So you can imagine a development team getting a feedback after a week that we broke something. And obviously trying to optimize anything upstream from that point is pointless, because if you change this value to, I don't know, 80%, still you will be blocked by this 10% here. So cleaning a bit this picture, what we realized and start to analyzing why we fail so much here in this step, we realized that that's the boundary when we entered into a multi-node environment. So staging environment was the first environment multi-node environments in our value stream. So obviously, our strategy was, okay, we need to make development environments multi-node just to be able to find errors connected with multi-node environment, like, I don't know, parallel requests, some racing conditions, and so on, to make them here. And actually, we made an investment to have this, to try to make it possible that we have multi-node environments for developers. And at least in our case, we try to do it using Docker and Docker Compose. When we try to imitate our production infrastructure, maybe not one-to-one, but logically, that there is a load balancer, there are processing nodes, there is, I don't know, 2 databases, one MySQL, one MongoDB, and so on. And that's the way we try to deal when optimizing feedbacks and flow throughout the system to reduce the lead time. Okay, and this is one of the examples. And our road with rollouts looks like that. By the way, on horizontal axis, you have rollout duration, so how much time it took. And on the vertical axis, downwards, you have consecutive rollouts. So yeah. And our statistics look like that. The blocks, they're just steps in the rollout. And we had to experiment. I mean, any kind of analysis, thorough analysis, didn't move us any closer. We did some analysis, but when we got stuck thinking, okay, what we should do next, we just, okay, let's try something new. Let's try this and not spend too much time analyzing possible effects. And when you do experiments, you fail. So sometimes you may experience major increase in your rollout duration. But eventually, the message was, or the message is, that by experimenting, the trend was that we started to have smaller durations of our rollouts, which is some kind of a proof for us that this is a complex problem and not complicated one. If it was complicated, then pure analysis would be enough. At least in our case, experimenting with deployment pipeline and with rollout was the way to try to reduce the rollout duration. And even if you look here, you would recognize that some of the blocks disappeared, like the purple one, because we found out that we can automate this process. It was quite a hassle, but we made it. Okay, I mentioned flow. I mentioned feedback loops. Now let's talk about organization. Typical traditional organization are organized like this: that you have 4 teams, for instance, 4 teams: development team, QA team, ops team, and infosec team. And when there is a project happening in the company, then certain managers of that teams, they assign resources to a given project. So the type of leadership present in such companies is typically command and control. This means that obviously leaders of a given teams or the system forces them to do local optimizations. And usually IT is treated as a cost in such a system and not like a value creator. People, as I mentioned, are treated as resources, so maybe it's not that hard to replace them, or maybe there's not that too much attention paid to people and interactions between them. Usually such companies experience poor lead time because of many handoffs, which happen here. And there's limited feedback loops, because there is lots of walls from certain teams. Lots of walls which provide the feedback to travel back to the development team, for instance. So this is the most traditional way companies may be organized. Some kind of evolution. Of course, this kind of companies are called silos companies. Those kind of companies, if they want to become more high-performing, they need to evolve towards some kind of matrix organizations, when still such walls exist, but people start being organized in teams around products. So this basically means that people have 2 bosses. One boss resulting from being in a dev team, for instance, and one boss resulting from being assigned to project A or product A, you name it. And what has been observed in such companies is that people, it's not clear who is more important, or alignment to which axis is more important, or should I, as an employee, be more focused on what head of development says or what project manager or product owner says. And there's no simple rule which will answer that question, and this ambiguity is some kind of risk in such a setup. And this means that still some management overhead is needed to prioritize, and the outcome depends on the direction of alignment, if it's vertical or horizontal. And these companies can be high performing, but they don't necessarily need to depending on the direction of alignment. And the pattern which emerges among high performing organizations is that there is a platform team whose specialty is around tools, practices, infrastructure, security, you name it. And they build a platform for services teams which create products. And those services teams, they are independent of other teams, and they build solutions end-to-end with the platform provided by platform teams. So responsibility of the platform teams is towards services teams, and services team responsibility is towards end customers. And this is some kind of product organization. Specialties, depending on needs, are existing in platform team, different specialties like dev, QA, ops, security, you name it. And depending on the needs of services team, they also exist in the services team. And the outcome is that such service teams, they focus, their focus is mainly on product and minimalizing lead time. So they want to deliver things to production as fast as possible. And the responsibility is end-to-end of those services teams. And such a structure encourages collaboration inside, because there are no handoffs. Inside the team. And people generally are T-shaped, so they need to have a solid fundament of different skills and be expert in at least one area, like development or sysadmin or quality. And what some leaders don't understand is that they don't understand how structure of an organization can be an obstacle for DevOps implementation. It's not that the structure of organization will enhance DevOps transformation to happen, but it may be an obstacle which just may make it harder to do. Another thing, have you heard about postmortems? Okay, good. Half of you. This is an example of a postmortem from one of the companies I was cooperating with. There was a problem on production. I will explain later on what was the problem. But anyhow, the team drew a timeline and tried to put on the timeline every relevant event which was directly connected with the problem which happened. And they started drawing it from the most present event up to a past. So what was the problem? Intentionally, some things needs to be erased, not to reveal the identity of a company. But anyhow, a certain amount of transactions on production failed. Money was collected from users, but users were not able to buy goods. So you can imagine a situation when you go to a shop, you pay with your card, you get information from a terminal that the payment failed, but then you log into your e-banking system and you see that the money is collected. This is this kind of problem. And the way to deal with this, I mean, the company, they realized around 7 a.m. that something wrong is happening. They were able to react in 7 hours when the fix was provided, or a patch, and they also had to manually make reversals for those people whose money was collected. And the key thing was, when the team started to analyze what happened, was that at night, when there is a settlement process, settlement is when all the money is computed and transfers are made to different, I don't know, merchants, companies, which should get the money resulting from payments. At 3 a.m. the settlement failed, and failed in a way that settlement component was a consumer of messages, and it stopped consuming messages. And on the other side, on the other backend system, which was sending messages to a queue, it started sending the messages up to a moment when the queue was filled. When the queue was filled, the number of threads on the system side started to fill up because the threads started to be suspended because the messages were not saved in a queue. So the thread pool on one side started to be filled, and suddenly transactions were not processed because of thread pool being overused. And the funny thing was, what the company realized, one of the guys, he had this tendency before going to work to wake up, check before going to work if everything is fine on production. If not, he wanted to provide a fix. He had a VPN access, so he implemented a fix around 7:30. He started fixing. He deployed the fix after 8 AM, but he didn't tell anyone about that. And the other person which was responsible for monitoring production environments observed that something bad happened, and suddenly it started to work. And this is how they realized eventually that there was a lack of communication between them, and people started calling the company that something is wrong with their money, and they had to cross-cut this information with what happened in the morning. And suddenly it appeared that the guys who was fixing stuff, he was not expecting the approaching iceberg. Also, the analysis showed that some time ago, similar problems happened, but they never ended up so severely. And as a result of this analysis, people involved in the postmortem, they defined the problems they had and solutions they proposed. One of the problems they defined, okay, that monitoring was not enough, that maybe instead of monitoring only the queues, we should also monitor executor thread pools. But there's one guy being a single point of failure, the one who provided the fix, and as a result, everything is blacked out, but the result was that there should be some internal training. And the key thing about this postmortem is that it's not possible to have it if there is not enough trust and safety in the company that people can admit to errors. And some leaders, what they don't understand is that creating a safe to fair environment and trust reinforces early detection of weak signals. And successful DevOps companies, what they do, by admitting that we are in a complex systems, not complicated, they need to train themselves in detecting ever weaker signals to be able to react before an actual catastrophe happens. In case of this company, the weaker signal meant that instead of monitoring only the queue size, we should also monitor the thread pool size, or the consumption of threads in the thread pool, which means that they are able to foresee incoming problem a bit earlier. And maybe another problem will happen in production, and maybe if they make a postmortem in a safe to fail environment, they would realize that maybe they should pay attention to even something else which will help them detect problems even earlier. And this was an example of culture, which was mentioned here several times. Which has been mentioned several times already. And these are the 3 pillars of DevOps. So optimizing the flow, optimizing the feedback loops in the opposite direction, and culture, which is a fundament for everything to happen. And if you talk to companies about DevOps and describe practices, mindset, culture, you can hear different replies that we don't have people skillful enough. I think it was CTO of Netflix who said, he was asked when Netflix described their DevOps practices, he was approached by other companies and he was asked, where do you get people from who are able to do this kind of stuff? And he said, I hired them from you. So this is something about culture, right? Some companies would say, okay, but there's too much legacy systems in here. State of DevOps report done on a yearly basis shows that both companies doing legacy systems or working on legacy systems and doing greenfield projects are able to implement DevOps practices. Other companies would say we don't build portals. Obviously not, but there is, for instance, a case study of Hewlett-Packard and their continuous integration of drivers for laserjet printers, when they decreased the lead time, I think, several hundred times by improving the way they worked with software. We must conform to regulations. Amazon, which I think is one of the biggest credit card processors in the world, they need to be PCI compliant. If you happen to work in a financial industry, you know what being PCI compliant means. One of the things is that, for instance, developers don't have access to production both ways. I mean, updating production and also getting feedback from production. And Amazon was able to bypass that, conforming still PCI compliance rules. And my favorite one, but you don't understand, and our company is special. I hear it very often. Every company is special, and I agree with that. There's a context, every company has its context, but still, if you understand the ideas, then obviously you are the one responsible to how to implement on your companies. So what is your excuse for implementing DevOps transformation? And basically that was it in my talk. If you want to have any questions, please ask them now. I don't know how much time we have. 5 minutes.
We have 5 minutes, so if you have any question, just raise your hand.
No one wants to challenge me.
Anyone? Nope. Okay.
Thanks.
Thank you very much, Tomasz.